Hey fans, we are going to be looking at how to factorize single brackets in this video. This continues from the previous videos on expanding brackets. So just what we know about expanding brackets, let's have a look. So if we were asked to expand the following, so 2 brackets a plus 4 or 2 lots of a plus 4, well, we would do 2 times a, which is 2a, and then 2 times 4, which is 8. Now, going this way is expanding, or we can also say just using the distributive law. When you are going in the opposite direction, this is known as factorizing. So, loosely speaking, it's basically adding the brackets back in. Now there's various ways we can add these brackets back in, and we're going to look at how we can decide to do this. I'm only going to be looking at single brackets for this. So a few other things that we need to remember and understand in order to do this is a factor multiplied by a factor will give you a product. So a product will consist of factors being multiplied. For example, a factor of 12 is 3, another factor of 12 is 4, 3 times 4 is 12. Now you can't pick any factors. For example, 1 is also a factor and 2 is a factor of 12, but 1 times 2 is not 12. We're just saying these happen to be 2 factors of 12 that are multiplied to give you 12. So here we can see 4a is the product. The 2 factors are 2 and 2a. Now we could show the first 2 of these questions in another way. So we can say 1 times 12 equals 12. So 1 and 12 are factors. We could also say 2 times 6 equals 12. So 2 and 6 are factors. In all of these cases, the product is 12 and the factors can change. So looking at example 3 here, AC times B. Well, AC is a factor, B is a factor, and it gives a product of ABC. So other factors of ABC might include A, B, C, AB, AC, AB, AC, and BC. Also 1 is a factor because usually 1 times ABC equals ABC. And then obviously ABC itself is also a factor. And then we get to the main point here. So here we've got a bracket that has been expanded. So what this is telling us is the factors of 3ab, or at least one pair of factors we can list, are 3 and a plus b. So a plus b is considered to be a factor of 3a plus 3b. So let's look at this in a bit more detail. Just before we continue, if you want to practice how to use the distributive law from the previous videos, have a go here, pause the video and have a go, and then I'm going to show you the answers in 3 seconds. Okay, so if you've done the practice, these are the answers for you to self-assess, and then we're going to move on to factorizing. Okay, so let's list factors. So factors of 12 include, we can do these in pairs. Pairs is a nice way to do it. So 1 times 12, 2 times 6, 3 times 4, and then 4 would end up being repeated, so you're going to do 4 times 3, which you don't need to write because we've listed all the factors here. Now this is a list. We could write 1 times 12, we could use a multiplication sign, but we're just going to leave it as a list. So those are the factors of 12. Can you list all the factors of the following? Pause the video and have a go with that, and then I'm going to show you the answers. Okay, so here are the answers to all the factors of 12, factors of 4a. You may have forgotten to write the 1, that's really important. You may have also forgotten 4a. So be careful you're not silly with those types of listing factors. And then for ABC, those are all the factors. And then for 3a plus 3b, those are all the factors there. So this is the interesting one. We want to know how to factorize 3a plus 3b. Well, there's two ways of writing it, and you're going to see why this method, this answer here, is going to be the one that we're going to use to help us to factorize. Right, so looking at highest common factor. So we're looking at the biggest thing that goes into 10 and 15. Pick from the list of 4, and then I'm going to show you the answer. Okay, so the highest common factor of 10 and 15 is 5. What's the highest common factor of 16 and 24? Okay, so we know it's not 16, because 16 doesn't go into 24. 12 doesn't go into 16, it does go into 24. 4 does go into both, and 8 goes into both, but 8 is the highest common factor. So 8 is your answer. What's the highest common factor of 28 and 70? Okay, so we know 7 goes into both. 14 also goes into both. 28 doesn't go into 70, and 10 doesn't go into 28. So the highest common factor is going to be 14. Because 14, so 7 times 10 is 70, so we also know 14 times 5 is going to give you 70 as well. Okay, next, highest common factor of x and x squared. Okay, so we know that 1 goes into both. 2x doesn't go into either of them. 2 doesn't go into either of them, so the highest common factor is going to be x. What's the highest common factor? Which of these is the highest common factor of 2ab and 4ac? Pause the video if you're not sure. So we can see that 2 goes into both of these things, so it's going to be one of these answers. We don't know which one yet. And then we know that a is common to both, so 2a is going to be your answer, not 2ac, that doesn't work. And 2 is a factor, but it's not the highest common factor. Okay, what's the highest common factor for 8x squared y and 16xy? Okay, so we can see 8 goes into both 8 and 16, and that eliminates the other option, so it's going to be 8xy, because x and y also go into these. Now the reason we were doing this is we need to make sure we can spot the highest common factor of algebraic terms, because we're going to be using that to factorize. So this is just a visual representation of what we're looking at. So if we know that 3 lots of a plus b is what we're representing here, that basically means we've got a plus b and then we've got 3 lots of it. So here's a second and here is the third. And therefore we can represent this as 3a plus 3b. So remember, what we want to do is go from the without brackets expression into the factorized expression, which has the brackets in it. So we can say, in other words, we've got 3 lots of a plus b. And that's telling us the same thing. So what's here is the same as what's here. Right, so let's look at 6a plus 6b. We want to factorize this. Now we could take out a few factors here, and I've listed lots of examples. We can do 6a plus b. If you expand this, you are going to get 6a plus 6b. You could also take a factor of 3 out. If you expand this, you're going to get 6a plus 6b. You can take a factor of 2 out. If you expand this, you're going to get 6a plus 6b. And you can also just take out a factor of 1. And again, you're going to get the same answer. So the question is, which of these, 1, 2, 3, or 4, do you think has been factorized fully? So all of these have been factorized. Only one is being factorized fully. You may have realized that for some of these questions, you can still take factors out. So for example, in this bracket here, we can still take 6 out. It's common to both. in this bracket here, we can still take 3 out, it's common to both. In this bracket here, we can take 2 out, which is common to both terms. Now, for this bracket here, there's nothing else that's common inside the bracket. So we can say the one that's been fully factorized is this. And so we need to be careful how we factorize when we're given brackets like this. Now, decide whether this has been fully factorized. True or false. So we can see from here that 8 and -6, we can still take a factor of 2 out from here. So this has not been fully factorized. The highest common factor of 16 and 12 is going to be 4. And then we have to decide 4 times what is 16. Well, it's going to be 4. 4 times what is -12x is going to be -3x. So this would have been fully factorized. This has only been partly factorized on the top. Now let's look at a formal method for factorizing. This is going to be continued in the next video.